this topic is titled Triangles and Parallel Lines. Yeah, it's kind of explanatory the way it is. So let's just dive right in. What you need to know before this stuff will make sense to you is you need to know the angles that are associated with parallel lines. So you can go back and look for a video where I talk about that. Okay, so we have a triangle inside of a triangle. Put some letters in and name these triangles with letters. I'm using wicked exciting letters today. Right straight in the alphabet, right? Okay, so what are we given? Geometry is big about starting with things that are given because you're supposed to look at them and be able to make some conclusions based on that. So we are told that CD, that's a symbol for parallel. CD is parallel to FG. They also tell us that EC equals 16, CD equals 40, FG equals 25, and they want us to know they want us to show what EF equals. Alright, so I'm going to change color pens, and we are going to rock this out. What I want to do, to show that something's parallel, this is usually what we do. It certainly doesn't hurt to do that. The thing is when we have parallel lines, this angle is going to be congruent to that angle. This angle is going to be congruent to that angle. The triangles both share this angle. If you've studied similarity, if you have two triangles that have congruent angles, they have to be similar. When we have what we can conclude from this stuff here, this one line, we've marked it all up, but now one of our conclusions can be that triangle ECD is similar to triangle EFG. Big whoop, right? Well, what it's going to do is it's going to allow us to be able to set up a proportion. Triangles that are similar have congruent angles, which we already know, obviously we've marked it up like that, but they also have proportional sides. So I'm going to take all of the measurements that they gave us and stick it in here. So we have EC, that's 16. We have CD, which is 40, clearly not drawn to scale. FG is this guy here, which is 25, and they want us to figure out what EF is. So since the two triangles are similar, what I can do now is set up a proportion, and a proportion is just a fancy way of saying that we're going to have a fraction equaling a fraction. Since this is the first one we're doing together, my fractions are going to be a side of a big triangle over the corresponding small triangle side, and that's going to equal another side of the big triangle over its corresponding side of the small triangle. Let's put numbers in this. That might make it click a little bit better. Fraction equals fraction. So for the big triangle, I'm going to go with 40. It's just popping. It's staring at me. And what is the side of the small triangle that corresponds to that? Oh, it's FG, which is 25. Notice I put the big triangle's measure on the top, small triangle on the bottom. Got to do that for my next fraction. Big triangle is 16. And what I need to show is that the smaller corresponding side is x. So I have the big triangle, small triangle. Big over small equals big over small. How do we solve these suckers? Cross multiply. 40x has to equal, I need my calculator. What is 16 times 25? That equals 400. I feel like I should have known that. To solve for x, what do? We divide both sides by 40. And x is going to equal 10. So what we want to do now is look back at our picture and see if that kind of makes sense. This guy here is going to be 10. That's not a whole lot to make sense, but at least we got a number less than 16. So if we got like 17, 18, 32, any of those, we would be like, no, I definitely messed something up. Alright, let us try to find, let's go do another problem. Next up, I'm going to be real sneaky and I'm going to flip those triangles, well, right side up, I was going to say upside down, but just different from how we had them. So here we go. Whoa, it's so exciting. Again, I'm not going to claim to draw these to scale. Let's do W at the top, X, U, V, Y. Things that we are given. They're going to tell us that XY is parallel to UV. Very exciting. They're going to tell us that WU equals 39. WV equals 52. WY equals 28, and they want us to figure out what WX equals. Okay, so same deal as before. We're going to take the parallel lines. We can mark it up like this. That's how you show that lines are parallel on a diagram. You don't really have to do this, but I'm going to do it just this last problem to kind of emphasize. They share this angle W. These other pairs are all congruent. Therefore, we can say, this is a symbol for therefore in case you never knew it, therefore we can say that triangle WXY is similar to triangle WUV. That means that we can set up proportions. This is kind of like what your brain needs to think about. You don't always need to like write it all down. It's good. Like it really shows that you know your stuff. And but you don't have to write that out. I just want you to, your brain is, this is the logic. We got this information, we concluded that the triangles are similar, we can now set up proportions. Alright, so let's plop in all of our values. WU, that's this big guy, is 39. WV, this is the other big guy on the other side, is 52. WY, which is the little guy here, is 28. They want us to find WX, so I'm going to call that X. Switching colors one more time. Alright, so I want big over little equals big over little. So big is 39. Its corresponding side is X. Equals big on this side is 52 over the little corresponding side is 28. All we do now is cross multiply. Double check. Big over little, yes, equals big over little. Sweet. I don't know that number. 39 times 28. 1092 has to equal 52 times X because we're cross multiplying. Let's divide 1092 by 52. And we're going to get that X equals 21. I checked on my calculator. I did not do that in my head. A quick check. Let's glance up here. X is the smaller triangle. We got a number smaller than 39. We're somewhere in the ballpark, so we can just figure that that's okay for now. Alright, let's try another one. If you're feeling pretty brave, what I want you to do on the next problem is the same thing I always want you to do if you're feeling brave. I want you to write down the problem, hit the pause button, do the problem in your notes, all these notes that like next to where you just took all those notes, then hit play and see if we get the same answer. Oh, I'm an upside down triangle again. Alright, let's say we have Q, R, S, and we'll do O and P for these guys. Stuff that is given. I am going to do one more after this. They're going to tell us that OP is parallel to RS. They're also going to tell us that QR equals 20, SP equals 15, QS equals 25, and we need to find out what RO equals. I went to high school with a girl named Roro, but it was actually her nickname for her name was Rosemary, so we call her Roro. So I haven't thought about that in a long time. Anyways, let's mark up our picture. We're showing that the lines are parallel by that, so that if anybody trips into the room and can't read my messy handwriting over here, they can look at the picture and go, oh, I know those double arrows means those are parallel. Let's mark up QR is 20, QS is 25, SP is 15, and we need RO, which is X. Okay, so what we're going to do is we're going to set up a proportion. We need fraction equaling a fraction. So we're going to do big over little equals big over little. That's just my MO. You could do little over big all the time. I don't care. But since I'm the one teaching it, I'm going to do it my way. So here's a big. 15 plus 25. What does that equal? Carry the 1. That's going to be 40. Over the smaller triangle is 25. Equals, this big is going to be 20 plus X over the small, which is 20. Cross multiply. Let's see, that's going to be 40 times 20 is going to give me 800. Equals, don't panic, 25 parentheses 20 plus X. Hey, we know our algebra, right? We're going to distribute through. So we have 800 equals 25 times 20, I'm pretty sure I should know that. I was going to guess 500, and I would have been right. So we need to bring the 500 to the other side to try to isolate our x, so we subtract it. I'm going to scoot over here. 800 take away 500 gives us 300. So the 500s here are gone, so that's going to equal 25x. We divide both sides by 25. How many quarters are in $3 is basically what I'm asking you. And there's 4 for each one, so it looks like that's going to be 12. Should I double check? Because I'd be foolish. I make enough mistakes without realizing it. Yep, so x is 12. So that little piece here is 12. That makes sense to me because when I look at this side here, I have 25 is bigger than my 15. 20 is going to be bigger than my little 12, so I'm a-okay with that. Alright, I promised you one more, so you got one more to practice with. This will be the one where you're going to hit pause, for sure, if you haven't done that yet. Do the problem out, come back and hit play. When I'm taping these, you guys probably can't tell, at least I don't think you can, that I hit pause and I save it as I go through it, because that way if I mess up and it's like my third example, if I haven't paused it and saved it throughout the thing, I have to start the whole video over, and trust me, I make enough mistakes that I've learned to pause it, save it, and then go back to it. But I'm getting anxious because like this video is already over 11 minutes long. I did my algebra videos for my algebra course. They're a lot shorter. Not really sure why, but I guess it's just the nature of the beast, so I'm not going to stress out. Alright. So we have T at the top, U, R, S, V. Given that UV is parallel to RS, UR is 12, VS is 15, TV is 25, and they want us to find TU. Alright, write this sucker down, hit pause, work it out in your notebooks, come back and hit play, and let's see what we got. I is gonna switch colors, mark this sucker up. So we want to show parallel lines, which gives us similar triangles. I'm going to start putting in some values. UR is 12, VS is 15, TV is 25, TU is X. Again, my method is big over small equals big over small. So this big side, the side of the big triangle, it's 40 once again. Over the small side, which is 25, equals, this big side is 12 plus X, over the small side is just X. We got a little more X's than normal, but don't let it phase you. So our equation is 40X equals that, which is very similar to what we just had in the last problem. Don't forget to put the 12 plus X in parentheses. Alright, so it's a little bit more of a complex algebraic equation, but that's good. We need to brush up on our algebra. First thing we want to do is distribute through. So we copy this side without changing anything. Did I already have 25 times 12? That's my 300, isn't it? Yep. 300 plus 25 times x is 25x. So I got the 40x hanging out over here. I'm going to make the 25x join him. How do I remove it from the right-hand side? I need to subtract it to make it go away. 25x minus 25x, beauteous. On this side, 40 minus 25, that's going to be 15. Don't forget the x. Now to solve this, just need to divide both sides by 15. And x is going to equal, 15 goes into 30 twice, 20. There we go. I hope you got the same answer as I did. If you need any clarifications and I'm hanging around, why don't you come find me.